Hi everyone, welcome back. Today we're solving maximal rectangle. So this problem is pretty straightforward. We will be given a binary matrix filled with zeros and ones, and we want to find the largest rectangle that we can form that's containing only ones, and we want to return its area. So if you look at this example, the largest area would be 6, so we return 6. In this example, it doesn't have any ones, so the area would be 0. And in this example, this 1 by itself would be the area, so it would be 1, and we return 1. So now that we have seen some examples, let's get to how we can solve this problem. So we can solve this problem using dynamic programming. We will iterate row by row and column by column within each row, and we will initialize 3 arrays, and I'll name them heights, left, and right. And heights will be an array that represent the maximum heights of ones at the specified row and column, and left would be an array representing the leftmost column that can form a rectangle at that column. And for both left and heights, we will initialize all values with zeros, and for right, it will be an array representing the rightmost column plus 1. So we will take the rightmost column and add 1 to that value. So the rightmost column plus 1, that can form a rectangle at that column, and we will initialize all values with the length of the row. So if the length of the row is 5, we will initialize all values to 5. And one more thing, for the leftmost column and the rightmost column, it has to match the height. So for example, when we are here or here, the leftmost column will be 2 and not 0 because the height is 2 that we can make here. So that's why it would be 2. And similarly, when we look at the rightmost column here, it would be 0 plus 1 because column 0 plus 1 because the height here would be 3. So the rightmost column would be here and not here. And also, if you're wondering why I said the height is 3 and not 4, it's because we are iterate row by row. So when we get down here, it will only be 3. And once we get down here, then the height would be 4. But up until this point, the height is 3. So yeah, after figuring out the right, left, and heights array, then we will calculate the area of all the rectangles by using this formula, right of C minus the left of C, and C is for column, and that would be like the length, and the heights of the column, that would be like the width. So when we multiply them, we get the area, and after calculating all the areas, we have returned the maximum area that we have found. So let's go over this example real quick. Initialize left to all zeros, heights to all zeros, and right would be all 5s because the length of each row is 5. Now the leftmost we can make right here is 2, and this is 0. And right, the rightmost we can make is column 0 plus 1 and column 2 plus 1. And the heights would be 1 and 1, 1 over here and here at these places. And obviously the maximum area we have found so far is 1, so we set result to 1. At the next row, we see that these 3 will all be index 2 because this can form a rectangle, and the leftmost column is 2. And also this is 2 because it can form a rectangle with a height of 2. Right here, the rightmost column would be column 2 plus 1, which is 3 because this has a height of 2, and this will be at 0 plus 1, so the height is also 2 here. And for these 2, it would be column 4 plus 1, so that's why it's still 5 for these. And the heights are 2, 0, 2, 1, 1 here. And the maximum area we have found so far is 3, so we set the result to 3. Now at the next row, we see that these are all still 2s because the leftmost column is 2 and the height is 2, that's why. And this one is 2 specifically because the leftmost column is 2, where it can form a rectangle with a height of 3. And for these 2, the leftmost column will be at 0. Now if we look at right, so this would be column 0 plus 1 because height is 3. This right here, since the height is only 1, it can just go all the way to 5, so 4 plus 1. Same for these 2, and for this one it has a height of 3, so it will be column 2 plus 1, so that's why it's 3 here. And the heights are 3, 1, 3, 2, 2, and as we can see, the maximum area would be 6, and we get that by taking 5 minus 2 multiplied by 2. So 5 minus 2 is 3, and 3 times 2 is 6, so we set the result to 6. And finally, at the last row, we will have this to 3, and since these values are 0, we reset all these back to zeros, and this has a height of 4, so we keep this as 0. With the right array, we see that these are zeros, so we reset them back to 5. Now this would be column 3 plus 1, so 4. This would be column 0 plus 1, so 1. And when we calculate these areas, none of them are larger as 6, so we keep the result as 6. And now that we have come to the end, we can return 6 as our result. And the time complexity would be OR times C where R is the number of rows and C is the number of columns, because that will be the number of ones and zeros that we will iterate through, and the space complexity would be O of C, because the length of left, right, and heights would depend on the number of columns. So now let's get to the coding part. So first we will initialize left to 0 times the length of matrix of 0. And for right, we will do the length of matrix of 0 times the length of matrix of index 0. And for height, it will be the same as left, 0 times the length of matrix of 0. Now we will initialize result to 0, and now we can iterate through the rows and columns. So for R in range length of matrix, now at each row we will set the current left to 0 and the current right index to length of matrix of 0. And now we can iterate through the columns. So we will do for C in range length of matrix of 0. Now we'll first take care of the left array. So if matrix of RC is equal to 1, then we increase the height array by 1, and left of C would be the max of left of C, or the current left index. Otherwise, if the value is 0, then we will reset height of C to 0 and left of C to 0. And the current left would be C plus 1. Now we'll take care of the right. So we will iterate backwards for the right side. For C in range length of matrix of 0, minus 1, comma, minus 1, and comma, minus 1. Now if the value is 1, then we will take the minimum of right of C and current of right. Now if it's 0, we will reset the right of C to length of matrix of 0 and set the current right index to C. Now, after figuring out the right and left array, we will calculate the area. So result will be the max of result, or height of C, times right of C minus left of C. And finally, we can return the result. See if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.